Okay, we have the questions on page 532 to go over, and they're really all with EMF is equal to BLV sine theta. And I'm hoping, for the most part, they're easy. There's a couple that are a little tricky or weird. Number 1, a wire segment 31 meters long moving straight up through a 4 to the negative 2 Tesla magnetic field at a speed of 15 meters per second. So 4 times 10 to the negative 2 Teslas, it's 31 meters long, 15 meters per second, and it's straight up through, indicating angle is 90 degrees. And so you should get an EMF of 18 volts, I believe. Oh, 18.6. Too bad I can't make out my own writing. 18.6 volts. Number 2, again, EMF is equal to BLV sine theta. A wire 20 meters long, 4 meters per second, it's moving 0.5 Tesla field, and it wants the EMF again. So 0.5 Tesla, 20 meters long, moving 4 meters per second, and it says perpendicular. So EMF should be 40 volts. Number 3, an airplane is traveling 90 kilometers per hour. So you have to change that to meters per second. If only I knew what I did with my calculator. And I said 90, but it's really 950 divided by 3.6. All right, Earth's magnetic field. So you're looking for EMF again at a spot where the Earth's magnetic field is just 4.5 to the negative 5 Teslas. It says the airplane wings are 75 meters, and they're what's acting like the wire. And when you change 950 kilometers per hour to meters per second, it's 263.8 repeating. And when you multiply these out, you get 0.890625 volts. Number 4. A straight wire, 0.75 meters long, moves straight upward through a horizontal 0.3 Tesla field at a speed of 16 meters per second. So again, EMF is equal to BLV sine theta. EMF is equal to, so it was a 0.3 Tesla magnetic field. It's 0.75 meters long, and it's moving 16 meters per second, and again, it's perpendicular. And you get 3.6 volts. There's a part B that says the resistance in the wire is 11 ohms. So what's the current? So V equals IR. So I equals V over R. So 3.6 volts over 11 ohms. And you should get 0.327, where the 27 is repeating. Number 5. Says a 40 centimeter wire moved perpendicular through a magnetic field of 0.32 vertical. Okay, so first step, find your EMF, BLV sine theta. So 0.32 Tesla, 40 centimeters, so 0.4 of a meter, and it's moving at a rate of 1.3 meters per second, and again, perpendicular. And so you get 0.1664, I think that is. Yeah, volts. 1664 volts. But that's not the end of the question. It says it has a resistance of 10 ohms. So what's the current? So again, V divided by R. So 1664 volts over 10 ohms. I should be equal to 0.01664 amps. Number 6. Jennifer connects both ends of a copper wire, total resistance 0.1 to a terminal's galvanometer, 875 ohms. Okay, so first find your EMF, because it tells you your B, your L, and your V. So B is 2 to the negative 2 Teslas. L is 10 centimeters, or 0.1 of a meter, and 1 meter per second. So you get your EMF to be 0.002 volts. And then it wants I again, so V over R again, so 0.002 volts. And the R, it says the galvanometer has a resistance of 875 ohms, and it says the resistance of the wire is 0.1, so 875.1 ohms. And you get a current that's really tiny, which is good because that's what the galvanometer likes, 2.285 times 10 to the negative 6 amps. Number 7. The direction of a 0.045 Tesla magnetic field is 60 degrees above the horizontal. 2.5 meter long wire moved horizontally at 2.4 meters per second. Vertical component of the wire, so of the field. So it's making an angle here of 60 degrees. This is 0.045 Teslas. The vertical component, it's just going to be the B sine theta from the equation, right? So 0.45 Teslas times the sine of 60. And you should get 0.03897 Teslas. Now your book does it this way because they just use the equation EMF is equal to BLV and they don't put the sine theta in. So for us, we would just do it all in one step, and instead of doing the B sine theta separately. Okay, and so that's part B, 0.045 Teslas. The length was 2.5 meters. The speed was 2.4 meters per second. And if we were doing it all in one step, we would just put sine of 60 here. And you will get an EMF of 0.0631 volts. Okay, number 8, switching back over here, says EMF, oh, this time you're going to have to rearrange, BLV sine theta. What is the size of the magnetic field? So B is going to equal EMF over LV sine theta. So it tells us the EMF is 0.02 volts. It tells us the L is 10 centimeters, so 0.1 of a meter. It tells us that it's moving 4 meters per second, and it says perpendicular. And so you should get a B of 0.005 Teslas. Number 9, also going to have to rearrange. EMF is equal to BLV sine theta, and this time you are finding V. So V equals EMF over BL sine theta. So it tells us that the EMF is 10 volts. It tells us the magnetic field strength is 2.5 Teslas. It tells us the L is 0.2 meters. And it says moving across, so again that would be perpendicular. So V is needing to be 20 meters per second. Okay, so those are all your homework questions. I'll do a separate video with the 2 new things for today.